Good afternoon, everyone, and welcome. I'm Pastora Martinez Samper, Commissioner for International Action at the Open University of Catalonia and Chair of the EUA Expert Group on Open Science. And it is my pleasure to welcome you to the 5th webinar of this EUA series dedicated to navigating the future of scholarly communication, which aims to address the rapid advancement and evolving scholarly practices which are reshaping the future of scholarly communication. Let me just, so as part of this current series, the EUA has already organized 4 previous webinars on diverse topics, and the series will continue next year with new webinars. In this case, as you can see, addressing the development of Open Research Europe, but also other topics to be decided. Our focus today is on a factor that has rapidly emerged as one of the most notable and interconnected forces shaping the future of research. This is the rise of artificial intelligence. And today we want to specifically discuss it with its interconnection with open science. In fact, since more than 10 years now, the EUA has been actively supporting universities in the transition to open science in close collaboration with the EUA Expert Group on Open Science and through evidence-based policymaking, regular consultations with its members, and also collective action. And in June this year, we published this EUA briefing that you can see in your screen, entitled Reclaiming Academic Ownership on the Scholarly Communication System. In this specific, discussion of this webinar, directly follows up on the findings of this EUA's briefing, which identified the rise of artificial intelligence as a key element requiring institutional attention. More precisely, AI has been identified as one of the factors shaping the scholarly communication system because it offers new forms of knowledge production, but also AI-mediated tools and practices introduce challenges and risks, particularly concerning integrity, reproducibility, misinformation, and biases. And on the other hand, the past 2 decades has seen growing support for open access to research outputs, and also the adoption of open science practices. But many publishers still restrict or complicate text and data mining, which undermines open access full potential, specifically as the ability to train AI systems using research outputs. And this is becoming more and more important. This is an exceptionally timely topic. Just recently, 2 months ago, the Commission published these both 2 strategies, AI in science and apply AI strategy, that demonstrates this clear commitment to accelerating the adoption of AI across the strategic sectors, including science. And furthermore, we saw the launch of RACE, this resource for AI science in Europe, just a few weeks ago. And these initiatives underscore the urgency and importance of the conversations we are having right now. Today, we will focus on the opportunities and the significant challenges that AI presents to open science. Our discussion will center on different foundational values, the integrity, accountability, also transparency in the use of AI in research. And we will explore these themes from different perspectives, also focusing in this interplay between open science and AI and the institutional insights required to navigate this landscape. And we are fortunate to be joined by a leading voice in this field, Tony Ross-Helauer. Hi, Tony, are you there? Tony is a meta-researcher based in Graz, Austria, where he's senior researcher and group leader with No Center Research. His background is in information science and philosophy, and his research uses qualitative and quantitative methods to investigate a range of issues related to scholarly communication, open science, and research assessment. Critically, Tony is the coordinator of Horizon Europe project, the Tier 2, which is currently investigating this vital role of epistemic diversity in ensuring reproducibility. And his insights today will guide us through this question of his presentation that are AA and open science friends or foes. And following Tony's presentation, we will open the floor to a discussion followed by your question, the questions of the audience. But let me just very briefly, before giving the floor to Tony, go to the some housekeeping details to ensure a smooth session. Regarding your questions, you have on the right of this platform and through the session, please use this Q&A box to submit your queries. We have the EUA team behind the scenes, including here Rita Moraes and Marina Polo. Thank you very much. They will be moderating also the incoming questions and the chat to organize them for this final panel discussion with you. Should you experience any technical difficulties, please reach out via the chat. We have also there Gemma Fagan, also from the EUA Secretariat. Thanks a lot, Gemma, who is providing our technical support today. You are also invited to explore the webinar platform. You will find there all the materials and presentations, the recording as well from today's webinar, but also from previous webinars organized as part of this series. And just as a final thing, and as we have today a diverse audience joining us, including institutional leaders, researchers, also admin and technical staff from different universities, we want to hear from you. We are going to begin a quick warm-up poll to gauge your current experience on AA. So go to this part on the thank you on the polling. You have it here for the first question. What is artificial intelligence for you? A friend, a foe, a stranger? Still figuring out. I will give you some moments to answer these questions. I can see that between a friend and still figuring out, I hope this webinar, will help you to have a more clear answer here. Yeah, Tony, you can see it. We have between the friends and what's going on there. Let's move to the second question, very broad. How do you use AA in your work, in your daily work? We want also to know if you are using it to support your research, the teaching, or the student support, the administrative tasks, all the previous ones, or you don't use AA at all. What are your things here? Yeah, so administrative tasks for the moment is the one that is given more responses, but there's also some people that don't use AA at all for the moment. So this is good to see, and that some of you are using it for supporting your research. Yeah, interesting. Not that much for teaching and student support. Okay, so let's move to the last question today. How do you expect AA to influence open science at your institution in the next years? What do you see? Will it transform scholarly communication significantly, improve existing processes moderately, have limited impact, or is too uncertain to tell for the moment? Yeah, so the answers here go from this idea between transforming significantly scholarly communication or even improving the processes somehow to some uncertainty here. Thank you all very much to give us this sense of what are your feelings behind these platforms from the audience. And now I will give the floor to Tony. Tony, thank you very much again for joining us today. The floor is yours.
Thank you so much, Pastora, and thanks to you and to all the EUA team for the very kind introduction. So my talk today is entitled Open Science and AI, Friends or Foes. As Pastora said, I study open science, and I'm based in an institute that specializes in artificial intelligence. So the confluence between these two themes is kind of a natural question for me. As is always the case with these kind of false dilemma titles, open science and AI, friends or foes, the answer will be a bit of both. And so in my talk today, I'll frame first kind of a bit of background on the development of AI, why it is so impactful for research generally. Then I'll talk about how open science and AI complement each other. Then I'll talk about some specific difficulties, and I'll end with some personal recommendations, reflections on how we might bring them into better alignment and make sure that AI works in the service of open science and open science works in the service of AI. So the first thing to say is AI research, AI-driven research, is not happening exclusively, or I'm not sure even mostly these days, in computer science departments. AI is driving many of the most cutting-edge methods in many disciplines. And so here in 2024, the Nobel Prizes in physics and in chemistry were both given to AI researchers, and you'll see the Nobel Prize in chemistry recipients there. Amongst them were people from Google. So AlphaFold from Google DeepMind is an AI system that can find how proteins fold. So it predicts three-dimensional protein structures just from sequences of amino acids. And it does this in a way that far outperforms humans. It used to be that there were very large competitions for this kind of prediction, and now it can take place at scale and down to atomic accuracy, according to Google. And so this is really a flagship and emblematic use case for how AI can help drive research and innovation. Starting with brass tacks, when we talk about AI is everywhere now. Since the explosion of interest sparked by ChatGPT 2 or 3 years ago, a lot of things which we used to talk about separately, information retrieval, natural language processing, recommender systems, have all now come under the term of AI, and AI as a term is everywhere. And in the European Union's Artificial Act, in fact, any algorithm that's used for inference to generate predictions or content or recommendations or help make decisions can be classified as AI. So this is a very large range, obviously, of computational tools that can help research. And generative AI is something that's really sparked the public imagination. They used to be called chatbots, but they're now so advanced that, and have such wide implications and potential that they've come into focus. So generative AI, when we talk about this, is just a class of AI that helps make new content. So it learns from millions, billions of parameters, underlying pattern styles, rules from data, and can then use that to generate new content, similar in style or structure to the training data, but novel in composition. And of course, there are known issues of the indeterminism. Often you ask the same question, it gives you two different answers. There are issues of hallucination, so just making up facts or content. And here kind of, at least within science, we know that it just generates false citations when trying to look credible. And also issues of bias, of course, and we'll touch on all of these. So the first thing to say is that there is real substance to the hype here. Here with regards especially to generative AI, but also to AI more generally. So in 2023, a large study was conducted in collaboration with the Boston Consulting Group, where consultants were given realistic management tasks, so realistic consulting tasks, which are normally very well paid and require expertise. And for tasks where AI was known to perform well, then the model GPT-4 increased speed by 25%, boosted performance, rated by humans here, boosted for performance by 40%, and meant that there was a 10% increase in task completion. But where the AI was known to not perform so well, then it decreased the correctness of results. And so the authors of this paper talked about a jagged frontier, which is it's not always entirely clear exactly where these models perform really well and where they don't perform so well. And over the last couple of years, the last few years, we've really been in a process of experimentation and finding out about these capacities. So are AI and open science friends? Well, the first thing to say is it's very interesting to look back on conversations from 10 years ago. And those of us who've worked in the open science space will remember a lot of conversations about the potential of text and data mining. And this was always given as a main rationale for open science, that data was the new oil of the digital age, that we, within research ecosystems, we were publishing papers, but we were leaving a lot of our results on the table, and we weren't publishing data, we weren't publishing software and code, and so many of these other outputs, and we weren't making them available in a way which allowed this text and data mining, so with open licenses. And so really, large language models especially are delivering on that promise of the text and data mining conversations from back then. So AI is really building on our work for open science. So when we think about what makes for responsible or trustworthy AI, this is a graphic from a 2019 report from the high-level expert group for ethics guidelines, and it defined these 7 principles of trustworthy AI, things like robustness and transparency, diversity, governance, societal and environmental well-being, accountability, and human agency and oversight. And I think it's very interesting to compare this with the principles of open science. So here they are as expressed in the UNESCO recommendation on open science from 4 years ago. And I think it's very striking that these are the same principles very often. Transparency, we want quality, collective benefit, equity and fairness, diversity and inclusiveness. So I really think that trustworthy AI and open science are in complete alignment. And then the question is, okay, so how do we make AI for science trustworthy? Here is a graphic from another report from the OECD from 2 years ago, just talking about use cases for AI more generally within science. And it really runs the gamut from hypothesis generation, so right at the start, right through design to implementation of experiment, simulation, and then of course inference, and even science communication. And many of us now maybe are using already these tools to help, at least in the refinement of our language within our scientific papers. So lots and lots of different use cases. Regarding the impacts of generative AI, here's a study from last year, from where I took this friend or foe title. And this was a Delphi study, so it asked a lot of experts about the potential, transformative potential of large language models in science. And it really struck home. It was interesting, the poll at the start about the use of these tools for administrative purposes, because this really came through in that study too, but also for creative and analytical tasks. And it showed that there was already rich experimentation looking at the potential for the use of generative AI in research design, in information retrieval, evidence synthesis, assessment of research, analysis of text, help creating code and analysis scripts, and also in dissemination. And I just want to stick to the point about where Gen AI specifically, but AI more broadly, can help open science. So I have been an open science advocate for very long, but I have noticed that it maybe tends to more and more be seen as an administrative burden. It appears in lots of policies. We need to comply for European, like for be in compliance with fund requirements, institutional requirements, and so talking to people, it can often be seen as an administrative burden. And if you think about it, a lot of what underpins open science is good documentation shared well. And I think that there's huge potential for these tools to assist in helping to document or automatize the documentation of our research. So open science relies to a large extent on good documentation, but there's a risk of administrative overload, obviously, and LLMs have potential here to help create data management plans or protocols, to pre-register studies, to document code, and to help provide good metadata for data, code, and materials. But of course, we need to ensure that these tools are trustworthy, and this is where the experimentation phase comes. And as another point, open science, or at least the access, so I tend to think of open science as aiming in three directions generally: enabling access to content, enabling greater transparency of processes, and opening participation, like enabling agency of researchers. So these three these 3 points. And if we think about the access point, we've really been engaged in enabling physical access to materials, like to making scientific studies available for others to read. But of course, scientific studies are usually written in such a way that they're not very understandable for general audiences. And here, we've reflected in a recent paper upon the potential for generative AI to help enable meaningful access, so cognitive access to content for societal actors, and translation capabilities, and help support information filtering. And so these are some heavy use cases where there's great potential for generative AI to help open science. But there are problems, of course. So considering where these things are in conflict, there's a great deal of talk over the last 10 years or so about reproducibility, and lots of kind of opinions, articles, and have flagged the idea of a replication or reproducibility crisis. Very often these come from specific disciplines, like psychology or clinical medicine. But these calls have also come from the AI community as well, as you see on the right. So let's talk a bit about reproducibility of AI research itself. So when I talk about reproducibility here, there are lots of different ways of defining these things, or reproducibility is something different from replication. Here I'm just talking at a very high level, and just that in general within science, if we conduct the same or similar study, we would hope to find the same or similar results, to know that we have robust knowledge. And this working definition probably covers most disciplines. There are some areas like qualitative research where maybe they might bristle with this, but this is a working definition. So here we can make a key distinction between being work that's reproducible in principle. That means that there is enough documentation to enable the reproduction of a study, and we can distinguish that from results reproducibility, which is kind of, if we repeat the study, then we get the same or similar results. Okay, so how is AI research faring here? So the answer is not great. A while ago, in a study of submissions to one of the flagship AI conferences, AAAI, Odd Erik Gundersen colleagues looked at kind of what was being shared, and you'll see that there is very little. They found very little sharing of experimental code, often of data, testing and validation data, and so on. So partially this is down to a lot of AI research being done in collaboration with industry, and there being things not being shared for competitions reasons, but there are lots of other reasons too. So with colleagues within Tier 2, we recently published this study, which looked at all the barriers to reproducibility in machine learning, and then also mapped those to things that can boost reproducibility. And so you can see here at the level of description, there's poor completeness and quality of reporting. There are a lot of spin practices and publication bias, limited access to code, data. There's poor methodology often, where the training data kind of leaks into the test data. So it's like the AI is studying for an exam that it already had the answers to. So methodological issues. And then there are some things about ML as well. Inherent non-determinism, the fact that very often algorithms we use, softwares we use, are very dependent upon the environment, the hardware that they run on, and also the fact that very often these methods require intensive computational resources, and so very often this isn't available to others to help replicate and so on. There's a need for a lot more standards in description and sharing of data to underpin. And here I'd like to flag the ML Commons, which is a consortium of, it started with mainly academic partners, but now it's academic and industry partners, which are working to create consistent standardized performance benchmarks. So one issue is that very often developers will create their own benchmark on which their tool performs really, really well. But the keeping these benchmarks consistent across studies so that we can really see which tools are performing better than others is a key issue. Collaborative approaches for AI safety, risk and reliability, and open ML datasets, tools and standards. And you can see that they're developing Croissant, which is a metadata format for interoperable machine learning datasets. we need to, as a scholarly community, we need to support these kind of initiatives a lot more, to bring AI in alignment with a kind of open science values. Thinking back to generative AI, and we talked at the start about kind of some of their deficiencies, just talking more about this now. So generative AI, it is amazing how good these bots are, but they're still bots, and so they're just probabilistic when they string sentences together. They're just probabilistic models that are saying this token probably goes after this token, probably goes after this token in response to a query. So Emily Bender and colleagues really talked about them as stochastic parrots. I think this was in response to some in Silicon Valley, kind of talking about the potential for generative AI to be a route to general artificial intelligence, or kind of human level intelligence. And they're saying basically it's not that. These things aren't thinking in a way that, in any sort of way that we would recognize. They're just probabilistic engines which put tokens together. And because of that, their reflections of their training data, we know the world is an unequal place. And in terms of the content that's available to train, there are inequalities and biases obviously in this. If you think about the content of the internet that's being scraped to provide kind of the training data for these things, mostly English probably, mostly coming from specific regions, languages, demographics, and cultures. And so within modeling, there's this idea of garbage in, garbage out. And here we could maybe say bias in, bias out. And so when we use certain generative AI engines, we really need to think, well, what training data lies behind this, and what are the biases which might be encoded within that training data, which might affect its use for scholarly purposes. If we think within qualitative research, for example, so there's a lot of kind of investigation of whether these generative AI tools can be used to help inference within or coding within qualitative research. But if the model itself is biased, then this risks biasing results. And this problem is exacerbated by a lack of transparency. So there's a really great resource from natural language process from linguists at Radboud University in the Netherlands. It's called the European Open Source AI Index, and they keep track of a huge array of large language models and other AI systems, and they map against different characteristics which we probably want to have for scientific purposes. So this is whether models are made open, whether the training data is open, whether they've published academic papers, whether there are model cards, or whether the weights, the kind of values which are used to weigh each of the features to determine how the model will run, whether these are open. And there's still a long way to go. So the people behind this resource published a paper a couple of years ago that said even amongst those that claim to be open source, and there really is a valid claim of open washing here, that people are using the open tag when really these aren't open. So we don't know where the data comes from, and very often maybe that stays hidden because it wasn't legal to train models using that data. Maybe there were copyright issues. Few share the all-important instruction tuning, so the weights, the feature weights. This is especially important for where human annotation labor is used. So human feedback is given. So we don't know in what ways the models were already biased, or in which way they've kind of been directed to give certain results as a result of human feedback. And there's very rarely careful scientific documentation. So here on the right, it's a very long list of large language models, but you see the top and the bottom, and amongst the bottom you can already see Grok from Twitter X. In the middle you'll see that GPT, so OpenAI, the people behind ChatGPT, did publish a quote-unquote open model with open weights, but lots of other elements remain closed. And although it's not included here on their previous scoreboards, I don't know why it's been removed, but the premium models of ChatGPT, these perform very poorly. Basically all the indicators are red for those premium models. There's an issue of fake content. So we're all aware that undeclared use of generative AI is a general problem, whether it's in the teaching that we do or in reviewing papers as editors. There is a really pressing need for us to work on better standards and better training as the kind of norms of how these technologies can and should be used evolve. There's a risk that the generative AI could aid misconduct and misinformation. So in paper mills, these are factories which churn out academic papers which may not contain good scientific information. But of course, generative AI is a real boon to these paper mills. And just as a kind of thought about the arms race that goes on as we introduce a new technology, open peer review, so the idea of publishing peer review reports used to be a kind of argument, or one reason for pushing for this was that it would eliminate predatory publishers, because predatory publishers are these publishers who don't really do any peer review but pretend to. And so publishing review reports, of course, was an argument that you would eliminate predatory publishers. But now these GPT, the generative AI, can easily produce a very credible, or at first glance, credible looking review report. And so we can see how there's kind of an arms race in the problems and solutions. There's also the possibility of using these large language models to just generate data sets from whole cloth. So sometimes synthetic data sets can be good for used for certain purposes, but here on the right is a paper which showed that large language models already a couple of years ago were able to create from whole cloth a fake data set that would support a specific conclusion in an academic paper. And of course, we need to think about equity and sustainability. So we talked about bias in the training data, but there's still issues of digital divide and barriers to using AI tools due to lack of infrastructure, lack of very basic infrastructure in some cases, lack of internet. But if we think of the kind of compute-intensive nature of a lot of these resources, even researchers in very well-funded institutions probably are lacking in comparison to some colleagues. So unequal access to AI resources. There's problems of concentration of power, dominance of a few tech companies in AI research, or centralized influence. And here we really need to think, I think, about how we engage with kind of closed proprietary models. One university here in Graz, for instance, has a contract to provide with OpenAI to provide ChatGPT basically for their whole university. But I think that this kind of use risks future vendor lock-in, and we're really just feeding a closed solution when maybe we should be thinking about community open solutions. And of course, there are huge sustainability concerns. Training these models consumes vast energy and resources, and even just querying them, every query you put into, say, ChatGPT, it's like pouring a couple of bottles of water down the drain just in cooling resources. And so we really need to think about where using these models really makes sense. So some final takeaways. This was a very recent report published in the last couple of months from the European Commission on the role of artificial intelligence in scientific research. And in the executive summary, under key conclusions, the very first thing, the findings reinforce that open science principles, open data, models, infrastructure are paramount for fostering innovation, ensuring reproducibility and trustworthiness of AI-driven research. So this underlines AI, especially in science, and here we're talking AI in science, it needs open science. Open science boosts the trustworthiness, the reproducibility of AI-driven research. And the report went on to say that policy support can expand and sustain these ecosystems, ensuring a fair and sustainable access to the required tools. So I guess this is speaking to policymakers, whether it's at governmental level, research funding organizations, and even EUA members, research performing organizations. How can we all foster this ecosystem that sustains AI that is in line with open science principles? So final slide, some recommendations. We really, in my view, really need to think about how to make AI and Gen AI technologies part of the scholarly commons. We think of the UNESCO recommendation on open science. Open science infrastructures are one of the core pillars. How do we make AI open science infrastructure? I think we should prioritize open source AI tools and models towards benefits of fairness, transparency, and reproducibility. We need to focus more on building collaborative infrastructures. So here in the last month or two, as Pastora said at the start, we've seen the announcement of the RAISE initiative, Resource for AI Science in Europe. And the idea is that there'd be kind of a virtual institute that acts as a CERN for AI in Europe. To what extent can we build on this in accordance with kind of open principles? And we also need to provide training and open guidance on AI model strengths and limitations and responsible reporting. We should make sure that anything that's being deployed is really tested well and apply safeguards to mitigate risks. We need to monitor the impacts in a proactive, ongoing fashion. And as I said on the last slide, I really think we need to think very critically about the resource intensity of these systems. Sometimes using some of these large language models is really, in terms of just the resources, is like using a sledgehammer to crack a nut. Maybe there are smaller models which are better for specific purposes. All of this needs experimentation and testing and a lot of sharing of results within the community. So with that, I will give the floor back to Pastora. I'm not sure if I ran long. I hope not.
No, not at all. Thanks. Thank you very much, Tony, for this comprehensive overview of what open science and AA, trustworthy AA, I would say, complement each other. So probably your answer would be that they are more than friends, right? Because you were mentioning this like a binomial, no, of two elements that can not just complement each other, but also be as catalyst elements from one to the other when seeing the principles there in that slide. Thank you very much. We have some questions in the chat. Also, the others, please feel free to put more questions there. There are many things that you've touched, many topics, several things there. Very large problems. How do we address them, because they are not obvious? Let me just start by the challenges we are having. There are some questions also in the chat here, and maybe let me start with these biases and how can we mitigate the biases. Let me just read one of the questions there. Just a second, I will try to find it. Because Peter Hannenberg said that they did the same prompt on the same Gemini. Thank you for that. The team of the EUA, you can read it on your screen. So on this Gemini Deep Research AI, but with different computers in different countries, and the results were different. What can you tell them on that, Tony?
Well, so these are probabilistic models. So the point is that it's not the result that it gives you won't be determined, and it can change its answer based on a lot of things. With these models, it's very difficult to say exactly what that is. So if it's from different locations, it may be that Google is weighting the model in such a way as to give different responses in different locations to different people. I don't know. But very often it's just the non-determinism of the model itself. And of course, this is a problem for reproducibility. With a lot of these models as well, you don't know exactly which version has been used, and very often they change things based on, for example, some large language models are trained to give shorter answers at times when they have a lot of traffic, you know, just to keep things moving. So you'll get a longer answer late at night than earlier in the day and things. And so, yeah, these are all parts of the problem in kind of thinking about applying these things to to science. Yeah.
What can we do at the institutional level or even at the European level? Is there something on that specific issue that could be done as a community?
Well, I think that we'll need to work more on kind of citation standards or standards for reporting of what was used when. You know, I use this model at the moment. Really, if you're using these proprietary models, you can just say, I use this model on this day at this time, and maybe publish the full answer, you know. But you'll never be able to step in that same river twice, just because of the nature of the technology and the fact that if they're closed models, you don't know what changes are happening under the same kind of version. So really, this is exactly the point why we need open, like really open models, where you know what the data were, kind of, you know, what biases might have been encoded, or at least these things are traceable, and that you know kind of when changes to a model might have happened. But again, it just supports the point. We need open science for these models.
Let me just ask you on that, on this interconnection between open science and trustworthy AI that you are mentioning several times in your speech. And yeah, with different discussions on open science activists on the field, there are like a kind of mixed feelings regarding to AI and how to use AI, and it's mostly concerning on the misuse of this content generated by Gen AI or AI tools that could lead, do you think, to a chilling effect on the discussions about the willingness to share results and data? And if yes, how could we as an open science community or advocates address this concern?
Yeah, it's a great point. So I did have conversations with people where they said, I didn't say that they could use my paper for this training, but they did, because they published a paper in with a CC BY license, you know. And I remember 10 years ago, conversations about open science, and especially with social sciences and humanities researchers saying, but hang on, I don't want CC BY. I don't want someone to be able to translate my my paper without me having a say, you know? And at the time, I think open science discussions were very led by STEM at that point. And at the time it was just, oh, come on, get with the program, you know? But no, absolutely. I think with regard to the big players, if we think about what they're giving back compared to what they're getting, then I think as a research community, we do have a right to be a little bit at least perplexed. But yeah, I think it leads to some people to reconsider kind of in whose interests are we sharing everything? Is it always for the public good, especially because there are these dynamics of cumulative advantage, you know? If you've got resources, if you've got the computing power, if you've got the experts in-house to take advantage of these open resources, then even though everybody seemingly has access to the same resources, there's the open science in that case is really just feeding the machine. The big players get bigger, you know. And I think that there is kind of, so equity in open science is one of the key priorities for the European research area over the next couple of years, which I think is fantastic. And I think reconsidering these kinds of questions is really in the interest of open science. I think open science, you know, it's reached this kind of more reflective, maybe critical point, and I think that we need a lot more reflection on these questions.
Maybe even more transversality, right? Because sometimes at some point the questions are raised in some specific communities instead of having a broad conversation on that, because now you were talking about a concentration of the power of computational power, also infrastructure power that is concentrated in a few takes, and also Europe is talking about how do we address this data and even infrastructure sovereignty, and everything is interconnected, as you were mentioning. So I'm not going to ask you how can we as Europeans solve that. No, let me just go to the specific topic of this series of webinars, which is related with the scholarly communication, because there are some points here, also some questions in the chat. And let me start asking you about this also, again, a risk or a challenge as we see AA related with academic misconduct or integrity, as you want to phrase it, no? What do you think are the most urgent areas where open science community need to invest? I don't know if there are technical solutions or community-led solutions in order to protect the initiatives and the integrity of the academic research. Tony, what do you think on that?
Yeah, so I think the main threat at the moment is to the integrity of the literature, but AI didn't cause this. You know, we know that the bad incentives of a bad system really caused this. I think it really is a problem just in maintaining, like for the preprint servers, for instance, have developed new policies because they're just getting deluged with kind of generated content. I think we fall back on kind of the strengths of kind of the academic community, which is kind of the communal use of peer review for scrutiny. Although there will be tools, AI tools in use very soon regarding that. So again, it's this kind of AI arms race. But we refocus on the reform of reward and recognition, because that's really the kind of the root of the problem, is that academia is skewed far more towards competition than to what Robert Merton would call communalism, you know, and that we really need to rebalance the kind of the acidity of the water that we're swimming in order to kind of incentivize bad actors less, I think.
Absolutely. Let me display a question that is in the chat by Seri Nazarovets that is also related with this scholarly communication on the transparency and specifically should transparency about DNA use be part of the control, and who should define the rules? Tony, what do you think on that?
Yeah, great.
What are your thoughts, at least?
Well, I have been working on something with colleagues regarding how we could bring generative AI into the scholarly commons. And to build a commons, you need to define exactly what you're trying to bring into the commons, so like exactly what the resource is, and then who are the community who will govern that, and according to which traditions or values or rules. So, yeah, I think what I'm saying is that as an academic community, we should be collaborating more heavily in order to build kind of shared resources, like making this basic infrastructure and pooling resources in such a way that they can be sustained, but also open and in line with academic values in terms of who makes the rules. So in thinking of a commons, very often, especially one for something as diverse as science, centralization isn't the way. Pluralism is the way. And I think that if we're talking about developing standards of use, then we fall back to scholarly communities. At maybe a high level in kind of a top-down way, a high-level way, then centralized bodies or kind of high-level bodies, policymakers, can set kind of principles or general principles. But if it's in terms of what will be the standards in use, then this should come from the scholarly communities themselves, especially like scholarly societies and so, I think.
Okay, thank you very much. So when thinking about scholarly communication, and more also there's an open debate here of there's also a need to reform it somehow. You mentioned peer review and how also EUA can incorporate here also some risk and some challenges as well. But on the positive point, in which areas do you see that scholarly communication can significantly benefit from EUA in the future, near future? I don't know.
Well, I think there's huge potential for AI in peer review. Like, so peer review burden is a big theme. It's just getting more and more difficult to find reviewers. Distribution of effort there as well. There's these kind of star reviewers who like take it very seriously. It's kind of a citizenship task, right? You belong to an academic community, you rely on peer review to get published, so you give back. But very often, lots of people aren't being asked, you know, because of logics of accumulation. The same people tend to get asked all the time. It's a few people doing a lot and a lot of people not doing. And so if we can use these tools to help in that process, I think that this will be huge. And there's lots and lots of experimentation going on. There are certain areas of kind of fact or correctness which they might be able to help with. I don't think, I mean, one of the comments in the chat was whether these tools would be like an AI buddy or whether they take over tasks.
Displayed here.
I think, yeah, it's always with. It's never either or. It's never us or the AI. It's always with. But then it's the question is on what's the terms of the with, you know? And we need to be sure that we are keeping kind of the critical oversight. So there's kind of within the AI literature this idea of human in the loop. When do you need to tell the human what critical information at what critical points for which decisions, you know? And so this is partly a development of the tool, but it's also a development of norms and workflows and so on. So there's lots and lots of work, yeah, to be done there. But I do think that there's lots of potential for AI to make things a lot easier. You know, it's not, we started and it was either people didn't know so much or they were friends. And from the way we've been discussing, I hope it's not that most people are now that have gone into the foes category. I do think there's a lot of reason to be optimistic.
So in this optimistic, there's a question with the most voted in the chat. Let me display it in this. And do you know if there's an impact of generative AI on the number of quality of, or is on your proposals?
I haven't seen a study on this. It's a fantastic question. My response would be, we need to ask the commission, I'm sure, like, without doubt. The thing is about proposal writing is very often some parts of it are boilerplate, you know, that we're reusing text from the same proposal and changing it. And again, it's always with, you know, if people are able to use these tools to write better proposals and conceive better projects, then this, I think, is great. You know, if the European Commission is being flooded with 3 times the number of proposals just because there's lots of AI generated junk coming in, then this is not so great for them, you know. And so I think we just see how we go. We'll just be always developing the norms and kind of, and if there are like real risks, then we will need to develop the kind of responses or the oversight to it.
So we will leave it here. Thank you very much, Tony, because we are running out of time. There are some questions left on the chat. Sorry for that, but we will continue. This is going to be an open discussion, open dialogue. Hopefully you find it as interesting as I found it this afternoon. Thanks again to our guest speaker. And thanks to all of you attending the webinar and also raising the questions. I encourage you to check the content on the platform for more information and links. And the recording of this session will be sent to you by email. Thanks again, Tony, and thank you very much. Have a good afternoon.
Thank you so much. Thanks, everyone.